Both of these apps do the same thing. Both let you sign up, both let you post a photo, both let you like and follow, feature for feature. They are identical. So why is one of them broken? Because building an app is not just about what it does. It's about what it promises, speed, uptime, the fact that your photos still exist tomorrow, the fact that someone else can't read your private messages. This is the difference between functional and non-functional requirement. It's the second most common interview question in the system design and the single most common reason real world system fails. Most courses give it 2 slides. We are giving it 10 minutes. By the end, you will be able to name the 6 non-functional requirements every system is judged on in any interview without missing one. Let's get into it. Every system has 2 kinds of requirement, just 2. The first kind is functional. These are the things the system does. The features: user can sign up, user can post a photo, user can send a message. Take these away, the app wouldn't exist. Functional requirement answer: what does this system do? The second kind is a non-functional. These are the things the system guarantees, the promises. The app responds in under 200 milliseconds. The app is available 99.99% of the time. Your data is never lost. Take these away, the app technically still works, but nobody can use it. Non-functional requirement answer: how well does the system do what it does? Beginners obsess over features and feel productive. Senior engineers spend their time on the guarantees because that's where system actually break. Stick this in your brain forever. Functional is what your system does. Non-functional is what your system promises. Forget either one and your design is incomplete. Here's the analogy that will stick. You walk into the restaurant. There are 2 things this restaurant has to get right. The first is the menu: pizza, pasta, burger. The menu tells you what they serve. If you order a burger, they say we won't make burgers. That restaurant is broken. The menu is a functional requirement. It's what they do. The second is the promises. Your food arrive within the 15 minutes. The kitchen is open 24 hours a day. The food is fresh, never spoiled. Each branch makes the same pizza the same way. Your card details don't end up on the internet. These are the non-functional requirements. The restaurant didn't sell you open at 11 a.m. as a feature. But if they are closed when you show up, the menu doesn't matter. Here's the kicker. A restaurant with a beautiful menu and 0 promises is a disaster. The pizza that takes 3 hours. The food gives you food poisoning. The kitchen is closed half the time and you will never go back. A restaurant with a smaller menu but rock solid promises, that's the place that survives. Same with your system. A feature-rich app that goes down every weekend is worse than a simple app that just works. Users don't think in terms of features delivered. They think in the terms of did the thing I needed work every time. That's why senior engineer cares so much about non-functional requirement. They are the entire point. There are 3 reasons functional and non-functional requirement matter more than anything else. Reason 1. Interviews. The very first thing a system design interviewer expects you to ask is what are the functional and non-functional requirements. If you skip this step and start drawing boxes, you have already failed. Even senior candidates open with these 2 questions every single time. Reason 2. Real production system. Every outage you have ever heard about, every angry tweet about slow loading times, none of those are functional bugs. The feature still works. It just doesn't work fast enough or often enough or safety enough. Non-functional failures are what makes the news. Reason 3 is career growth. Junior engineers are hired to implement features. Senior engineers are hired to think about guarantees. The day you stop asking what does it do and start asking what does it promise and what happens when it fails, you have grown up as an engineer. Here's where we are going. On the left, the functional side, the features. Things like user can sign up, post a photo, follow people, easy to list. They map to product requirement docs and Jira tickets. On the right side, the non-functional side, the guarantees. This is where the engineers spend real time, and there are 6 categories you need to memorize. Every interviewer expects all 6. Here they are. First, latency. How fast does the system respond? In the restaurant, food arrives in 15 minutes. In your system, the page load in under 200 milliseconds. Lower latency means a snappier app. This is what user feels. Second, throughput. How much can the system handle at once? In the restaurant, we can serve 200 dinners per hour. In your system, we handle 10,000 requests per hour. Throughput is about volume. Latency is about speed. Don't confuse them. A system can be fast for one user and slow for 10,000. Next is availability. How often is system is up? In the restaurant, open 24 hours a day. In your system, up 99.99% of the time. 99.99% uptime means under 53 minutes of downtime per year. 99% uptime means 3.5 days. The difference is huge. Durability. Once the system stores data, does it stay stored? In the restaurant, food never spoils in the freezer. In your system, photo uploaded today are still there in 10 years. Durability is about not losing data ever, even when hard drive fails. Next is consistency. Does everyone see the same data at the same time in the restaurant? The same pizza recipe at every branch in your system. If you like a post, your friend sees the new like count immediately. Consistency gets surprisingly hard at scale. And most systems compromise here. That's the whole future video. Next is security. Is the system safe for bad actors? In the restaurant, your card info stays safe. In your system, data is encrypted. Only the right people can access it. Security isn't the feature you add at the end. It's a guarantee you build in from day one. That's all 6. Every system in the world is judged on this. Memorize them in this order and you will never forget one in an interview. I want to be honest with you about something most courses won't tell you. The good news, once you know these 6 categories, every system design question become a checklist. You ask the interviewer about each one. You write down concrete numbers. Latency under 200 milliseconds. Availability 99.19%. Strong consistency required. The problem has a shape and you can start designing. The bad news, you can't optimize for all 6 at once. Maximum availability means duplicating data across regions, which hurts consistency. Maximum throughput often means giving up strong consistency. Maximum security add latency. This is the trade-off triangle from the last video. With more corners, every real-world system picks 2 or 3 of these to prioritize and explicitly accept weaker guarantees on the others. So here is the rule. Don't say the system should be highly available, highly consistent and lightning fast. Say this system prioritizes availability and security. Accept eventual consistency. Target sub-second latency. That's a designer thinking. Even from this video, you can confidently handle 4 of the most common opening interview questions. Question 1 is, what are the requirements for this system? Don't just list features. Split your answers in 2. Functionally, the system needs to do X, Y, Z. Non-functionally, we need to talk about latency, availability, durability, and consistency. Naming both categories put you ahead of most candidates. Question 2 is, what's the difference between availability and durability? Availability is about system being up. Durability is about the data being safe. A system can be down for an hour and still be durable because when it comes back, your data is there. A system can be up all the time and still be non-durable. If it loses your data when a disk fails, different problem, different solution. Question 3. What is the difference between latency and throughput? Latency is one user experience. Throughput is everyone's experience combined. A pizza shop with one fast oven has a good latency but bad throughput. A pizza shop with 10 slow ovens might have bad latency but great throughput. Design for whichever matters more. Question 4 is, how do you choose which non-functional requirements to prioritize? You can't prioritize all 6. Ask the business, what's the cost of being slow? What's the cost of being down? What's the cost of losing data? The answers tells you which corner to optimize for. That's the conversation you should be having with the product team before writing any code. That last one alone will make you sound like a senior engineer. Trust me. Before you go, take 30 seconds to log this into your mind. Takeaway 1. Every system has two kinds of requirement. Functional is what system does. Non-functional is what it guarantees. Forget either one and your design is incomplete. Takeaway 2 is, memorize the 6 non-functional requirements: latency, throughput, availability, durability, consistency, and security. Every interviewer wants all 6. Most candidates only name 2 or 3. Takeaway 3. You cannot maximize all 6 at once. Real system picks 2 or 3 to prioritize and accept weaker guarantees on the rest. Your job as a designer is to name the trade-off out loud before drawing a single box. In the next video, we will zoom into the 4 pillars every system is judged on: scalability, reliability, availability, and maintainability. They sit right on the top of these requirements and they are the words you will use to describe system quality for the rest of your career. If this helped you, hit subscribe so you don't miss the next one. The full playlist is linked below. See you in the next video.